Consciousness can be seen as the awareness or subjective experience that arises within certain systems. It is the ability to perceive, reflect, and interact with the world in a meaningful way. However, consciousness is not just a passive observer. It actively engages with and shapes the reality it perceives. Consciousness cannot be understood in isolation. It is deeply interconnected with the systems that contain and manifest it, and the complex structures that emerge within these systems. The triad of self-contained systems, A, complexity, B, and emergent properties, C, provides a framework for understanding how consciousness arises from the interaction of these three elements. Each plays a crucial role in creating the phenomenon of consciousness, and their coexistence is essential for the system to function. Self-contained systems, A, refer to entities that maintain a distinct boundary and internal organization, enabling them to function independently within a larger environment. These systems are self-contained because they possess the mechanisms to regulate their internal states and sustain themselves over time. Examples include cells, organisms, ecosystems, and even the universe itself. A key characteristic of self-contained systems is that they arise naturally, with boundaries that separate them from their surroundings, allowing them to operate as autonomous units. Complexity B emerges as these self-contained systems interact with their environment and with other systems. Complexity is not merely about unpredictability, but rather about how simple components and interactions through repetition and feedback loops give rise to increasingly intricate patterns and structures over time. For instance, the complexity of a living organism arises from the multitude of interactions between its cells, organs, and systems, all governed by fundamental biological processes. As complexity increases, it sets the stage for the emergence of new properties and behaviors that cannot be reduced to the system's individual components. Emergent properties, C, are those novel characteristics or behaviors that arise from the complexity within self-contained systems. These properties are not present in the individual parts of the system, but come into being when the system operates as a whole. Emergent properties can include consciousness, metabolism, or ecological balance, phenomena that emerge from the complex interactions within and between self-contained systems. These properties are essential to the functioning and evolution of the systems themselves, providing new capabilities and adaptations that allow the system to thrive in a changing environment. In the context of consciousness, emergent properties include higher-order functions like self-awareness, intentionality, and subjective experience. These properties are the result of the complex interactions within self-contained systems and cannot be reduced to or fully explained by the system's individual components. The concept of coexistence within this triad suggests that self-contained systems, complexity, and emergent properties are mutually dependent. Self-contained systems, A, provide the foundational structures within which complexity, B, can develop. As these systems grow more complex, they begin to exhibit emergent properties, C, that enhance the system's functionality and adaptability. These emergent properties, in turn, reinforce the system's complexity and stability, ensuring the system's survival and evolution. Without the presence and interaction of all three elements, consciousness as an emergent property would not arise. This interdependence implies that consciousness, as an emergent phenomenon, is deeply rooted in the complex interactions within self-contained systems. Donald Hoffman's theory of perception as a construct created by conscious agents provides a clear example of how these elements coexist. In Hoffman's view, the mind does not perceive objective reality directly, but rather constructs a user interface that simplifies and manages the overwhelming complexity of the environment. Here, the agent is the self-contained system, A. Hoffman's agent is comprised of its own triad of functions, perception, decision, and action, that each influence and are influenced by the others to create complex neural processes, B. The interaction of these processes gives rise to the user interface, C, that humans tend to confuse with objective reality. Hoffman's idea that the objects that we perceive are not the objective reality, but icons in a species-specific user interface, reinforces how the brain, a self-contained system, uses complexity to generate emergent properties that shape our experience of reality. Hoffman's idea that processes at all levels can be modeled using conscious agents also demonstrates the importance of encapsulated systems for defining the internal rules, mirroring how consciousness requires individuation to process a subset of human experience. Freeman Dyson's reflections on the universe's interconnectedness also reinforce this triadic coexistence. Dyson suggests that the universe is structured in such a way that the evolution of complexity and the emergence of new properties are inevitable outcomes of the system's dynamics. In this view, self-contained systems, A, such as living organisms, are products of a universe that fosters complexity, B, leading to emergent properties, C, like consciousness and life itself. Dyson's idea that the universe shows evidence of the existence of a controlling force, the universe knew we were coming, implies that these three elements are not just coexisting, but are interwoven in a way that drives the evolution of conscious beings. As the self-contained systems that make up life evolve through increasing levels of complexity, they eventually give rise to the emergent properties that define conscious experience. This interconnected process where complexity leads to emergent properties within self-contained systems underscores the importance of all three elements in sustaining consciousness. Thus, the coexistence of self-contained systems, complexity, and emergent properties forms the foundation of consciousness. Each element is essential for the other's existence and function, creating a network of interactions that gives rise to the phenomena we associate with conscious experience. This triad emphasizes that consciousness is not an isolated property, but a dynamic outcome of the intricate relationships within and between systems. Consciousness arises from the complex interactions within self-contained systems, and these systems, in turn, are shaped and defined by the complexity they embody, enabling the emergence of higher levels of order. This interdependence highlights the importance of understanding consciousness, not as an isolated phenomenon, but as part of a broader system of interactions that give rise to and sustain it. While coexistence explores how self-contained systems, complexity, and emergent properties work together to produce consciousness, the idea of equilibrium examines what happens when these relationships break down. Equilibrium represents a situation in which the balance and dynamics that allow self-contained systems to function are lost. When the complexity within these systems dissipates, the emergent properties they once supported also disappear. This leads to a state of stasis or entropy, a point where the dynamic interactions that sustain consciousness cease, leading to the dissolution of the complex structures and systems that support it. In this state, without the continuous interplay between self-contained systems and complexity, the emergent properties that give rise to conscious experience disappear. Erwin Schrödinger provides a crucial perspective on this concept with his discussion of life as a fight against entropy. Schrödinger suggests that living systems, self-contained systems, must continually resist the natural drift toward disorder, entropy, to maintain their complexity and, by extension, their emergent properties. Without this resistance, the system would collapse into equilibrium, losing its complexity and the emergent properties that define it. Schrödinger's observation that what we observe as material bodies and forces are nothing but shapes and variations in the structure of space underscores the idea that without the internal complexity to maintain structure, self-contained systems, A, cannot sustain emergent properties, C, leading to a return to a state of equilibrium where consciousness cannot exist. Self-contained systems are crucial in this resistance as they maintain the order necessary for complexity and emergent order to exist. Without these systems, the complex interactions that give rise to consciousness would collapse, leading to a state of equilibrium where conscious experience is no longer possible. Schrödinger's notion that particles are just Schaumkommen, appearances, underscores the idea that the material world, and by extension consciousness, is fragile and dependent on the continuous maintenance of order by self-contained systems. Rupert Sheldrake's theory of morphic fields further illuminates this fragility. Sheldrake suggests that morphic fields, patterns of organization that underlie the structure of systems, are sustained by complexity. These fields contain an inherent memory that guides the development and behavior of systems, whether they are biological, chemical, or mental. These fields, which rely on complexity, B, to maintain their patterns, are essential for the emergence of new properties, C, within self-contained systems, A. However, if the complexity within these systems is lost, the morphic fields can no longer sustain their structures, leading to the collapse of both the systems and the emergent properties they support. In such a scenario, the system reaches equilibrium, a state of minimal energy and organization, where the conditions necessary for consciousness no longer exist. In this state of equilibrium, without the necessary complexity to sustain them, consciousness cannot persist, and the system as a whole reverts to a state of inactivity or dissolution. The equilibrium scenario serves as a powerful reminder of the delicate balance that sustains conscious experience. It highlights the fact that consciousness is not a given, but a result of continuous and dynamic interactions within systems of great complexity. If these interactions are disrupted, the entire structure collapses, and consciousness ceases to exist. This understanding emphasizes the importance of maintaining the conditions that allow for conscious experience. Integrating the analyses of coexistence and equilibrium reveals the cyclical nature of the interactions between self-contained systems, complexity, and emergent properties. Consciousness, as an emergent property, arises from the complex interactions within self-contained systems. These systems, in turn, are shaped by the complexity they embody, which continually generates new emergent properties. This cycle is dynamic and self-reinforcing. As self-contained systems engage with their environment and internal processes, they generate increasing levels of complexity, leading to more sophisticated emergent properties. These properties, such as consciousness, then feed back into the system, driving further complexity and evolution. This cyclical process highlights the idea that consciousness is not a static trait, but a dynamic outcome of ongoing interactions within systems. This cycle suggests that consciousness is both a product of and a contributor to the complexity and order that define our reality. Each iteration of the cycle builds upon the last, leading to an ever-increasing richness in both the systems that sustain consciousness and the conscious experience itself. However, this cycle is not infinite. The equilibrium analysis reminds us that the system's stability is contingent on the continuous interaction of all three components. If this balance is disrupted, if the complexity within self-contained systems is lost, or if these systems fail to maintain order, consciousness will revert to a state of equilibrium, ceasing to exist as we know it. This understanding not only deepens our comprehension of consciousness, but also highlights the need to preserve the conditions that allow consciousness to thrive. By recognizing the cyclical and dynamic nature of consciousness and its dependence on emergence within complex, self-contained systems, we gain a more holistic view of what it means to be conscious and the delicate balance that makes consciousness possible. The triadic relationship between self-contained systems, complexity, and emergent properties offers a powerful framework for understanding consciousness. Through the lens of coexistence, we see that these elements are deeply interconnected, each essential for the other's existence and function. This interdependence drives the dynamic processes that give rise to consciousness as an emergent property. In contrast, the concept of equilibrium reveals the fragility of this balance. Without the continuous interplay between self-contained systems, complexity, and emergent properties, the system collapses, leading to a loss of consciousness. By synthesizing these perspectives, we gain a deeper understanding of consciousness as a dynamic, cyclical process that depends on the delicate balance of interactions within complex systems. It is not a static phenomenon, but a process that evolves through the continuous interplay of systems, complexity, and emergent order. This understanding provides a way of interpreting and explaining consciousness behaviors, not just at the individual level, but in encapsulated systems of all levels, from cells to ecosystems, to help identify and interpret conscious action occurring at all levels of reality.